We're in business, baby, and business is a booming. Now, the only thing I can't figure out is why, perchance, the vertical isn't doing anything. Whatever. We'll come back to that. We are on Gamedev. Okay, let's switch this up. And I saw my reflection. What am I doing? There we go.
Hello and welcome. In this lecture, we are going to be setting up some lighting in our scene. We're going to add some sunlight and a sky, and we're going to also look at the 5 different types of lighting available to us in Unreal. Let's dive in and learn all about it. So if we were to switch from our currently unlit mode into the lit mode, you'll see that everything is 100% dark. And the reason for this is that we've got no lights in our scene, nothing by which to illuminate everything around us. So let's go ahead and create a new folder in the outliner, which we're going to call global. And this is going to be for stuff like global lighting. And then we're going to go to the quickly adds project and open up our place actor panel. And in
How do I get to my actor panel?
here, we're going folder in the outliner, which we're going to call global. And this is going to be for stuff like global lighting. And then we're going to go to the quickly adds project and open up our place actor panel. And in here, we're going to go to the lights tab and have a look at the 5 different types of light that we can put into our scene. Perhaps the simplest to think of is the point light. If I drag this into our scene, you can see immediately the kind of effect that it has. Light emanates from a single point outwards, and that's pretty much it. We can change how powerful that light is. We can change how it trails off. We can change the color of the light. But the fundamental property of that light is that it is a point source light. So let's remove that light now. And let's try a spotlight instead. So a spotlight, as the name suggests, has some sort of directionality to it, but it still emanates from a point. Now, I think these are very much like your standard kind of halogen lights, your spotlights.
Hold on. BP cell door. Crypt doorway. Isn't miscellaneous? Whatever. I don't care.
In your house. And obviously they can be very useful for trying to illuminate a specific area or a specific object. All these lights can be rotated, so obviously with a point light, rotation didn't make much sense. But with a spotlight, rotating allows us to illuminate different areas. So that's the spotlight. Notable mention just to the rectangle area light. Rather than being a point source here, you can see that the light's actually emanating from the entirety of this rectangle. So you can see if I point it down, it's just a wider area for it to come from. And obviously this would work well with office lighting or anything where you want to illuminate from a larger area rather than from a particular point. And then two interesting ones here that are more natural are the directional light and the skylight. You can see the icon for directional light looks like the sun. And that's because the most common use of it is, in fact, as a sunlight. So if I stick this in the scene, you'll notice that it doesn't actually matter where I place this actor. I could place it anywhere, and the light doesn't change. The only thing that's important here is the rotation of the light. If I change the rotation, you can see it changes the angle of these rays of the sun. And that's because the sun is so infinitely far away from us that essentially the light that reaches our scene is all parallel, is all going in a single direction, and that's why it's called a directional light. So the position doesn't matter because it's so infinitely far away that it shouldn't make a difference. And then the other thing, so if I delete this one out and we put our skylight into the scene, this is another one where the direction doesn't matter, but this time it's because the light is coming from all directions. And at the moment, it's actually not showing us anything very much at all. And if we go and have a look at the description of what a skylight does, you'll see that the light actually captures the distant light in our level and applies it to the scene as light. So typically the way we deal with this is by bringing in a massive sphere that goes around our entire level and simulates the really far off sky and distant horizon. Now, a place that we can go and find this is if we open up our content drawer, go to the settings button in it, and select Show Engine Content. And then you see an engine folder pops up.
Whoa. What?
Our content drawer, go to the Settings button in it, and select Show Engine Content. And then you see an engine folder pops up. Let's click on that. And inside that folder, we're going to search for Sky. Now, what we want is this BP Sky Sphere. We can go and drag this into our level. And you can see if you pop out of
BP Sky Sphere. All right. Well, first of all, let's just do this. Control Z, didn't mean to do that. Back that eyes up. BP Sky Sphere. Hello.
the level that we've now got a sphere here that is absolutely massive and basically simulates the far off distant sky and clouds and the sun in the sky. So that is what our skylight is trying to capture, the light for that. So we need to click on the skylight and we need to go scroll down to a property called Recapture Scene, and we click on Recapture. And you can see that the light now gets updated to represent that kind of soft twilight that is...
Homie, what?
We need to go scroll down to a property called Recapture Scene.
Skylight. Real-time capture? Is that... What am I... This one? I thought I just saw it.
And we click on Recapture. And you can see that the light now gets updated to represent that kind of soft twilight that is illuminating everything a little bit evenly. And that's what we wanted. And you can see inside it's still quite dark. We've only got a little bit of light spilling in from the outside, but it's given us a nice soft ambient light. So typically what happens is that we will put the skylight and the sky sphere together and also have a directional light on top of this as well. And we can set the direction of that light as we see fit by just kind of rotating it around like this. And if we then go back and select our sky sphere blueprint and look at the details pane for it, you can see that there is a link that it could want to a directional light actor. So we can select this asset by selecting the actor in.
Bro. Chicho, best viewers on streamboo.com. Remove the space. No thanks, dude. Thanks, but no thanks, dude.
Our scene to pick that directional light, and you can see that instantly what it has done is it's changed to a much brighter daytime and the sun is high up in the sky. And that's because by linking those two in together, what we've said is that the sky sphere should match the angle of this directional light. So if I put the angle of the light really low, the sun hasn't quite updated because we'd need to go in to our BP sky actor and hit refresh material, which then redraws it, and you can see the sun is now low in the sky, and the color of the sky has been automatically updated. So these two things being linked together is a really good thing. It makes them physically much more accurate. So I'm just going to put it back to the sun being reasonably high up in the sky, and then we can go to our BP sky sphere and just refresh its material one more time. Now these actors haven't gone in the global folder yet, so let's go drag them in there, and these are all the things that apply at a
BP sky, directional light, and skylight. All right, the skylight's not doing anything on mine because I don't have any freaking windows. You never said to put a window in, dude. It's a dungeon. Don't know why there would be windows. Don't know why there would be windows. Wait, we do lit. Lit. It's lit. Lit, lit, lit. Directional light. My boy.
that directional light, details pane for it, you can see that there is a link that it could want to a directional light.
BB sky sphere. Okay. Directional light actor, yes. Directional light, yes.
Actor. So we can select this asset by selecting the actor in our scene to pick that directional light, and you can see that instantly what it has done.
Instantly, what's this done? I would like to move around in here. It's giving me, this is really weird lighting, I'm not gonna lie. I'm not gonna lie. Why is this like this? What is it? Oh, nope. It's high noon. I mean, like, it's fine, I guess.
Is it's changed to a much brighter daytime and the sun is high up in the sky. And that's because by linking those two in together, what we've said is that the sky sphere should match the angle of this directional light. So if I put the angle of the light really low, the sun hasn't quite updated because we'd need to go in to our BP sky actor and hit refresh material, which then
BP sky actor and
our BP sky actor and hit refresh material, which then
oh, wow, ooh. Let's do that, and then let's do that, and then let's do that. Yeah. I think it should be kind of like midnight. Let's do that, let's do that, let's do that. Oh, is that morning or night? I mean, the lighting is still really gross. I think it's because there's holes in here. Is that right? Is that right, mate? Yeah, I mean, the light's getting in some way. All right, whatever.
Redraws it, and you can see the sun is now low in the sky, and the color of the sky has been automatically updated. So these two things being linked together is a really good thing. It makes them physically much more accurate. So I'm just going to put it back to the sun being reasonably high up in the sky, and then we can go to our BP sky sphere and just refresh its material one more time. Now these actors haven't gone in the global folder yet, so let's go drag them in there, and these are all the things that apply at a global level. So it just allows us to tuck them away nice and neatly. So I'd like to challenge you to add some sunlight to your own scene. So you're going to add a sky sphere, add a direction light and a skylight, and link them them together as I've just
Done.
done, so that when you
I just
move
did
the
it.
direction light, it can update the material for the sky sphere.
But it looks
And
terrible.
the sky light then can recapture the light from that sky sphere and change the rotation of the sun. Maybe you want a different mood to your game. Mine's more high in the sky, but you might want a lower sun to represent a later time in the day. Pause the video and have a go. Okay, welcome back. So, well, this is how I've got it at the moment. The only thing I want to check is the skylight looks quite orange, so I'm guessing we haven't recaptured the skylight. So I'm going to the skylight and then scrolling on down to where it says recapture. If I hit recapture now, you can see the skylight has gone far more blue in the shadows, and that's because the reflected atmospheric light in our sky sphere is more blue because of the sun being higher and the rays not getting scattered and all that kind of physical goodness. Now you may notice that some of the shadows here are looking rather strange. Don't worry about this just yet. We are going to fix this in a later lecture. So that's it for this lecture. We've looked over the different types of light that we can have in our scene, and the most complex setup being how we do sunlight. I'll see you in the next lecture.
Whatever, dog. Lumen and
Hello and welcome. In this lecture, we're going to be making the inside of our dungeon completely pitch black by adding some panels around the outside to essentially block out any light from bleeding into the dungeon. This is a preparatory step for the next one, which is going to be to actually light the dungeon. So let's dive in and see how this works. So when we were playing around with lighting in the last level, you may have seen that we instantly got some updates to the lighting, and if we brought in objects, we could instantly see the effects of those lights, and there's lots of scattered and soft bounce lighting. And this is due to a new development in Unreal 5 called Lumen. It's a real-time global illumination light engine. And because it's fairly new, there are still some features that are not supported in Lumen. And you can see this going on with this material on the wall.
Hello, how are you?
You can see how it's kind of got this weird shadowing effect.
What's
Well, this
up,
is because
Twitch
there are
Emma?
some features being used in its material that are not supported yet by Lumen. So what we need to do is we need to edit this material, and we can find the material for this particular segment like so. Click on the wall. Let's go down to the area where it says materials. And under the materials, you can see we've got this stone wall inst. If we select that in the content browser and we scroll down to the stone wall, what it means by inst, what's it mean by having that underscore?
Emma, Twitch Emma, what's up? What's goody? How you doing? How you living?
Inst at the end. Basically what it's saying is this is not actually the material itself. It doesn't tell it how to render the material. It's just essentially like a blueprint of the material.
Hello, Emma. Can you not hear me? Twitch Emma1, how are you? I am answering.
Material that tells it which textures to use and other settings. So what we need to do is right click on it and click Find Parent. And if we click Find Parent, then open the content drawer again, you can see we've got this M tiling master. Hovering over that does show us that this is indeed a material. This is the master material that the other materials are made from.
We go in here. Stone wall. No. What's the dealio?
You can see other settings. And under the materials, you can see we've got this stone wall inst. If we select that in the content browser and we scroll down to the stone wall, what it means by inst, what's it mean by having that underscore inst at the end? Basically what it's saying is this is not actually the material itself. It doesn't tell it how to render the material. It's just essentially like a blueprint of the material that tells it which textures to use and other settings. So what we need to do is right click on it and click Find Parent. And if we click Find Parent, then open the content drawer again, you can see we've got this M tiling master. Hovering over that does show us that this is indeed a material. This is the master material that the other materials are made from. So we can click this to open it up, and we now get the material editor. It's very much like a blueprint editor. You can see there's all these nodes here, except we don't have an execution pin. These are all just data pins. It doesn't really matter as to how this works exactly. The important thing is that all the output data is going into this node at the end, and one of the things that isn't supported in Lumen is this pixel depth offset. We basically can't use that. So we need to disconnect it. We can do that by alt-clicking on the pin. It can go away. Then we go to the toolbar and hit Apply, and it's going to go ahead and recompile the material code, recompile the shaders, and have that available in our level. Now, if we go over into the dungeon, you can see that weird shadow effect has gone away, and we've got a better looking level. So now it's time to start lighting the interior of our level. You can see there's a lot of light bleeding in to this interior of the level, and that is because actually our ceiling is a one-sided mesh, and so light's kind of coming through into the room. And we'd see this even more if we do the following. Because Lumen is a real-time system, it really works best when you use real-time lights. And what do I mean by that? Well, if we go to our global folder and select the directional light and have a look in the details pane, you can see that there is a mobility setting here. And this basically...
Jesus, you're moving quick, man. You're moving... Well, I actually got you on 1.5 speed, so... It's my own fault. Global.
it tells Unreal whether we intend to move or modify this object when the game is playing. So static means no, nothing is going to change about this object full stop, and that allows Unreal to bake in a lot of things like lighting settings before you play the game. There's stationary, which says you can't move it, but you can change things like the brightness. And then there's movable, which basically means anything could change. Now, funnily enough, Lumen, the new Unreal lighting system, works best when your lights are set to be movable. So if we switch our directional light to movable, you can instantly see the problem here that essentially the light is just coming straight through these ceiling panels because from the light's point of view, they aren't there. They're one-sided, and so it doesn't actually create any shadow in here.
Oh.
And we can do the same thing, set the other light in our scene to movable, which is the skylight, and that's just going to compute all of our lights in real time. It's much easier to deal with lighting when we're doing everything in real time using Lumen. So let's start having a look at how we can block out the light here. I think one of the easiest ways to do this is actually just to take the floor meshes and lift them up to be a roof over the top of our dungeon. That's certainly one way we can do it. So I'm going to go ahead and search the outliner for floor, and then look in the dungeon folder and just select the dungeon floor.
No, I don't want crypt floor. Come on, what are we doing here? What are we doing here? Huh? Dungeon floor. This is the one. Oh, baby.
Floor elements. Then I'm going to go to the floor pane view, and I'm going to pull the floor up while alt-clicking to duplicate it and bring it up to a level where it can be our ceiling here. If we go inside, I just want to check that it is indeed blocking out the light effectively, and it seems like it is. If you bring it too close, then you can get some light bleeding in. So we don't want it too close, but we do want it just close enough, like so perhaps. So there we go. We've not got any light bleeding into this room except from these corners. And if you pop out, you can see why. The edges are not quite meeting the top here. So what we need to do there is put some of that edging.
What? You want an edge, dude? It's pretty crazy, bro. I'm better than you. Oh, it is bleeding. Damn it!
Meshes around there. So if we look for edge in our medieval dungeon, we've got the edge stones. Let's drag those in and place them.
Edge stones. Where are ya? There you are. That's not at all what I want. That kind of is. Where is it on this? Ah, okay, here we go. And we'll just alt across the board. Is that right? Why isn't this guy here? Damn near perfect. Right, I mean, like
next to these objects and duplicate it along, maybe changing the grid snap setting to be 1 meter. And we'll duplicate and duplicate again. And we've got ourselves, hopefully, the light being blocked inside our dungeon. Yep, looks like it's being blocked quite effectively. And just for completeness sake, we're going to take these 3 edge stones, select them, and duplicate them over to the other side, like so, and then rotate them 90 degrees with a duplicate, and then duplicate it on over here as well. So you can see that inside now we've got a very, very dark dungeon. And if we wanted to check that we can indeed illuminate it at all, then we could just go to our quickly add, go to lights, and drag in a point light to see the effect of illuminating the dungeon.
Okay, let's do a point light. This can all go in ceiling. What is that? Oh, that might be an issue.
So I'd like to challenge you to block out the light. So you've seen how I've been doing it, add floor and edge stones around the whole of your corridors. You may need to rotate them so that you can cover some of the rounded areas, for example, around that mausoleum. And you might also want to check that all your corridors are dark once you've finished and there's no light bleeding in from any places. You need to cover them all up, make it all dark. So pause the video and have a go. And remember that you can use the unlit mode to move around when things are dark. So pause the video and have a go. Okay, welcome back. So let's remove this light from our scene because we don't need it. We just want to see whether we're making everything nice and dark. So what I'm noticing here is we've got the edge stone here that we don't really need because the edge is actually over here at the end of the staircase. It's a bit of a funny shape. So let's go ahead and move that edge along. Then I'm going to copy a couple of edge stones from the already built section and duplicate them to the other side of this corridor. Then select a couple of floor panels and move those along too. Now switching into unlit mode, let's go and position ourselves so we can see the staircase, then switch back to lit. And you can see that the staircase is looking pretty dark in here. We just need...
Oh, let's go to my staircase. Where the shiitake mushrooms is the staircase? I'm so lost. Where am I? Aha. It's lit. Pretty good.
Need to cover up the crypt area now. So we're going to select all of that crypt flooring. So I'm doing that by searching the outliner for crypt floor and then selecting all of it. I think I just need to be careful to deselect these two bits of floor at the start of the staircase. And it looks like there's this crypt floor wall trim to deselect as well. Then when I'm confident it's all at the same level, I'm going to Alt and drag it up to make a duplicate. Looks like I may need to change the grid snapping to be 50 because of the height of the ceiling. I can bring it up one level more. Now if I switch to unlit mode, I can position myself inside the corridor to have a little look. Go to lit, and I can see that it's starting to look quite dark. These architraves have got a bit of light bleeding, so I think I just need to position them probably 10 centimeters higher altogether, so there's not any light bleeding from those architraves, and then any of the edge that doesn't quite match up here, we're going to have to put some edging stone around that. So let me just go and check. We've got a little bit of an issue here where light's being let in from the backside of this decorative wall and also from the backside of these mausoleum meshes. So let's try and fix that by duplicating some roof and maybe rotating it down to cover this piece that was bleeding light. And if we want to be safe and have some margin for error, we could actually copy two of them across here so that there is absolutely no way light's coming in there. And we probably want to do roughly about the same thing with our mausoleum. Duplicate some wall down here, rotate it about 90 degrees, and then I'm actually going to duplicate it to be higher as well. And the flooring does need to be higher up on the mausoleum to let the whole roof fit. And I think these walls need to be a smidge further out to not include some of this mesh. Looks like we've still got some light coming in from somewhere. So I'm just going to duplicate a couple more panels like so, and along the top too. Switch to unlit. Let's go inside the mausoleum and have a look around. Back to lit. Okay, looks like it's just the edging stones to do now. Or actually, because this area is not going to be visible from the exterior, it doesn't matter how it looks, so we can just add some extra flooring like this and just make it extra wide. Then inside you can see that there's no bleeding going on. So we can do that same procedure with the rest of the corridor. Move some of it slightly across and then the rest over to the right. Switch to unlit, check I'm inside the corridor, and then back to lit. And everywhere apart from that door is looking completely pitch black. Is that true? Even when I'm looking up the staircase, I wonder. Let's have a look at the staircase. Hit lit. Yeah, it's looking pretty dark in here. Very, very dark indeed. So there we go. We've effectively blocked out any light bleed that we were getting inside our dungeon, which will set the stage for lighting it properly in the next video. I'll see you there.
I'll see you there.
Hello and welcome. In this lecture, we're going to be lighting the interior of our scene with torches and chandeliers and looking at the different lighting settings available to us to tweak the light intensity and various shadow settings as well. Let's dive in and see how this is done. Before we go any further, I noticed that I've got all these edge stones that are currently not organized in the outliner. So I'm going to take these and drag them into the dungeon folder so they disappear with that dungeon. Okay, now that we've got that set up, it's time to start lighting the interior of our scene. Now, my weapon of choice here is going to be to use the BP torch. If you search for that, then there's this great blueprint that's set up already with some nice flaming torch effect and a light as well. My only problem with this torch is that it's a little bit bright. So what we can do here is we can make our own version of the torch by going to the details pane, going to the blueprint button and going create child blueprint class. And I'm going to call mine the torch and then
create child, where are you? I want to birth you. Birth you. Where did you go? I hate that everyone.
With effect and a light as well. My only problem with this torch is that it's a little bit bright. So what we can do here is we can make our own version of the torch by going to the details pane, going to the blueprint button and going create child blueprint class. And I'm going to call mine the torch, and then we usually put the modification after it. So BP torch underscore dungeon. So this is going to be my dungeon torch. And we're going to place this in the root of content and click select. So that creates the torch. We don't actually need it open, but we can go ahead back into our level, and there's the torch right there.
Relax.
I'm just going to change my grid snapping units to 10 so that I can correctly place it on the wall, right, like so. So we've got our torch attached to the wall, and what I wanted to do is to modify a couple of properties of the light. If you have a look at the torch blueprint, you can see it's made up of a number of components. One of them is the mesh of the torch itself, one of them is the point light, and one is the fire. I want to change a few properties about the point light because it's not
think I can close out of that, but BP torch blueprint. No. I want control content BP torch blueprint. Oh, that was right. Oh, oopsie.
Not quite set up how I want it to. For example, it's not casting a shadow with this pillar, and that's because of the way this point light is set up. If we go down into the properties, you can see there is a cast shadows property that's unchecked. Let's check that first. There you go. We've now got some shadowing going on in our scene. Unfortunately, it's got this really ugly shadow here from the torch itself. So what we can do to correct just that is to select the torch SM torch mesh and then scroll down to its property or search for its property called shadow. And you can see that there is a dynamic shadow and static shadow. We can uncheck both of these.
Shadow.
And you can see that it's no longer got that ugly shadow. It's now just casting a nice light and shadowing with the pillars and with the scene around us. Now, the next thing to do when we go back to that torch light component is to just cancel out the search and have a look at some of the other lighting properties we've got here. One of them is the intensity. I think it's too bright. So I'm going to start by taking it down by a factor of 10 to 500. And for me, that just feels like a much more moody ambient light for a crypt and a dungeon. So I'm going to go with that. And we'll go back to the torch light again. And then there's the attenuation radius. This means how far can...
Oh. Control Z. Oh, that's moody, all right.
Can this torch cast its light? And actually making it smaller, making the attenuation radius smaller, has good performance impact because it's having to compute less shadowing. So I'm going to make it as small as I think is reasonable, which is just about, I think, 800 units is a good attenuation radius for me. And now
Sure, I don't really care.
all these properties, I've been making them here in the outliner, but if I wanted them to apply to all instances of my BP Dungeon Torch, so if I went to content browser and brought in the BP torch, you can see this one's really, really bright. So let's select the one that I've actually modified and made all those modifications to. And I'll go to the blueprint button again. And this time I'm going to select apply instance changes to blueprint.
Wowzers.
And that's going to make it so that all of the blueprints now match those changes that I just made. So that's what I'm going to do. You can obviously choose to set things up differently with your lighting. I'm going to add in a few more torches here to light my scene. I think another one on this pillar. I'm just going to drag it in and rotate it about 180 degrees. Seems to be well placed in the wall already. And then these little alcoves here are a bit dark, so I'm just going to switch to the unlit mode, place a torch on the wall and rotate it by 180 degrees, and then do the same on the flip wall. And then let's preview this in the lit scene. So you can see how it slowly adapts the lighting. This is both Lumen taking its time to work out the light calculations, and also the other thing that's going on here is that there's a little bit of exposure compensation going on so that it can handle very bright outdoor scenes, and indoor scenes it can change the exposure for. So I'm happy mostly with how this is lit. If we wanted to, we could put a chandelier in here. That's another blueprint that we've got. So we can search for the BP chandelier in the content drawer. Then we can bring it in and place it up here above. And the chandelier works a little bit differently. It's actually got some properties on the actor. So if you select the actor level of the blueprint, go to the details pane, and then check the add point light, you can see that it adds indeed a light for that chandelier. And we can change some of the properties of that light here. So
how the heck do you spell chandelier?
chandelier exposure for. So I'm happy mostly with how
Yep. Unlit. Is lit. Unlit. Have a shandy, baby.
This is lit. If we wanted to, we could put a chandelier in here. That's another blueprint that we've got. So we can search for the BP chandelier in the content drawer. Then we can bring it in and place it up here above. And the chandelier works a little bit differently. It's actually got some properties on the actor. So if you select the actor level of the blueprint, go to the details pane.
Chandelier.
And then check the add point light, you can see that it adds indeed a light for that chandelier, and we can change some of the properties of that light here. So we could change the intensity if we wanted to. We can change the attenuation radius. I think is definitely too small. I'm going to change that to 1000. Like so that kind of fills the room with a little bit more light from that chandelier up the top. So you could use a combination of the chandelier lights, the torch lights on your walls, and so on to light up the rest of your level. So that's going to be your challenge. Have a little bit of fun with it, lighting your level. Use some torches and chandeliers, experiment with the mood, create some blueprints for different configurations of lighting. So if you want to have different torches down in the crypt that are even dimmer, you could create a different child blueprint for that. And similarly with the chandelier, if you wanted to change the properties and use those properties in multiple locations, you could do that too. There's always the option of bringing in just point lights and spotlights and area lights if you want those as well without any associated meshes. Then you could just use that for lighting the specific elements of your level if there's things you want to draw attention to. And we'll be doing that a little bit later on in the section with some other elements in my level. So pause the video and have a go.
Pause the video and have a go. Wait, so the lighting is actually bleeding through up top? Unlit! It's unlit! Where am I? Bing bong. Bing bing bong, bing ding bong. We want baby torch blueprint. These are all going to be at X, Y. No, it's X. It's a Z that I want to with. I think you want to be at 300. $300. Torch. Oh me. Where am I? Homie. You in the wall or something? You are. Why would you not be oriented Oh, you too. Okay. 90. You right on that, Jimmy. And you gotta go 180. Where the holy cannoli am I? I should have done this before I turned the lights off. Where's the chandelier, darling? And why aren't you? Why aren't you in uniform? This is a well-lit dungeon, if I do say so myself. If I do say so myself. Hold up. Them boys. Control Z, meant to hit Alt. You need to move this way. Same with you. Not perfect, but perfection is the enemy of progress. Oh my gosh. All my shards. This is terrible. This is terrible. So bright. All right, so some key things that I've already messed up is having the double layer makes it really hard to modify anything on the overhead view. Although What? Candle tall used? Oh. That's interesting. Okay, so I decided what I'm gonna do. Delete all the lights. Come back here. And we are going to ding 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 ding. DP chandelier, create a new blueprint. DP shandies. And we'll save it at the content. Okay. Select. DP shandies. Alright. Bring this back. Bring this Jimmy John. Okay, that's pretty close. All right, now. Wait a second. I called it something else. Why is it? Okay, let's put this in. Oh, I'm silly. I'm silly. All right, fine. Whatever the class name is fine. All right. And add points. That's actually pretty solid. We're gonna move this way up here. Maybe not so much. Is lit. Can you turn this on and off? Actor hidden in game. It'd be great if I remembered my layout. Fuck. God damn it. Okay, wait, let's do... Aha. Dead on, baby. Please unclick. Oh my gosh, what is going on? No, how do I use paint? What even is this? Damn near close. All right, is there like a selection? What? Oh. One, two, three, four, five, six, 7, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so we are 1, 2, 3, 4, 5, 6. Ah, Control Z. Fuck you. Forget how this goes. What is F? If I worked backwards. Oh, good damn, Dad. Good damn. One, two, three, four. 1, 2, 3, 4. Bing, 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 bing. I'm pretty confident this is a dead end. Are there multiple ways to... Holy shit. One, two, three. This one. And then another here. And go up. Up. Boop. 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 Is that really how easy it is? Oh my goodness. Oh my damn. Oh my goodness. We're going ham. Alright, there's at least two solutions. Oh my goodness. 1, 2, 3. 1, 2, 3. What is the deal here? I can't. 1, 2, 3, 4. 1, 2, 3, 4. I'm a silly poopy head. I'm a silly poopy head. I mean, whatever. Like,
Okay, welcome back. So I'm going to basically fast forward through this. It's going to be more of the same, just me placing down these actors to light the level.
we haven't gotten to the hard part.
So that's me done. Let's go and have a little run through the level and I'll show you what I've done. Nothing's changed here in the main portion of the level. There's one light down here in the corridor. I wanted to keep it quite dark and mysterious for the great reveal. And I'm noticing this is not quite aligned as I wanted it to be, so I'm going to move it a bit more centrally like so. Then we go into the corridor and we're keeping it nice and dark and moody in here. We've got the door at the other end. I'm still not happy with the fact that there's so much light bleeding through this door, but oh well, we'll find a way to solve that another time, or I might not, but you might polish things off a little bit better than I'm polishing things. So here we go. I had to put a light here so that it would illuminate this little feature piece. Then we can come down the corridor and we see the open door and we come in to our nicely lit mausoleum, which has got a couple of torches on either side and a nice chandelier so that it's very well lit, because this is going to be an important room for us to understand what's going on and to see the railings that shut, etc. So that's it. That is my lighting done, and I will see you in the next lecture. Hello and welcome. In this lecture we're going to be setting up a game mode and a custom player pawn so that we can walk around our level as a first-person player, ready to play some gameplay mechanics. Let's dive in and see how this works.
Good.
So we've already seen how when I hit play, I just go straight through the floor here. So we kind of want to fix that so that we can play inside our level without fear of falling through floors. So the problem is that this SM floor mesh does not have any collision setup on it. So we can hit the Browse to SM Floor in Content Browser button. We can open up the SM Mesh editor and dock it to the main window. And hit play, I just go straight through the floor here. So we kind of want to fix that so that we can play inside our level without fear of falling through floors. So the problem is that this SM floor mesh does not have any collision setup on it. So we can hit the Browse to SM Floor in Content Browser button. We can open up the SM Mesh editor and dock it to the main window. And then we can go to the Show button and hit Show Simple Collision and see that there are no simple collision meshes.
I don't have a show button.
We can open up the SM Mesh editor and dock it to the main window. And then we can go to the Show button and hit Show Simple Collision and see that there are no simple collision meshes. To add one in, we're going to go to the collision button in the toolbar and go to Add Box Simplified Collision, which automatically adds it around the mesh. Now, just to make sure we don't fall through this floor, I want to make that box a little bit thicker. At the moment, it's kind of 0 thickness. So what we can do is go in the Details pane, scroll on down, where we're going to find the Primitives collision section, and then under it there is Primitives. And this shows us the different primitives that make up the collisions. And some of the primitives are things like spheres, boxes, capsules, etc. We've got boxes. So let's open up the box. We can see its center is here. We can see the rotation. We can see the
Whoa.
extents that make up the collision.
BRB. Okie dokie, artichoke.
And some of the primitives are things like spheres, boxes, capsules, etc. We've got boxes. So let's open up the box. We can see its center is here. We can see the rotation. We can see the extent, which basically means how large it is. And the Z extent is 0. So let's make that 10 centimeters instead. So you can see that's made the box slightly thicker. But I don't want our character to be standing on top of the floor, so what I'm going to do is I'm going to change its center to be at -10, so that basically we've got that box, but it's underneath our floor. So we can go ahead and hit save to the mesh, and now if we hit play, hopefully, there you go, we are able to walk around on the floor without falling.
Sprinting. Holy shit, these are pretty high. Sneak by ya.
Through it. Now there may be other meshes that you discover that have similar problems and that you can't you can pass through. In this case, the doors for me are not actually wide enough to fit my character, so I'm going to have to open these doors a smidge more. Okay, so now that those doors are wider, we should be able to fit through them no problem, and we do. And we can now walk around our level as a first-person character. However, this first-person character is set up for a first-person shooter with first-person shooter arms, and that's not what I want. So we're going to adapt this character for our own uses. So let's find where that first-person character is, and that's under the content first-person blueprints. And we've got first-person character in here. I'm going to right-click on it and create a child blueprint class, which I'm going to call BP_player. And this player, we're going to move to the root of content. Click move there. And then what we want to do is create a new default game mode and set this player as the default to get spawned. But before then, what we want to do is create a new default game mode and set this player as the default to get spawned. But before I challenge you to do that, let's modify this player so that we remove the arms that are there.
Wait. Oh, back that ass up.
Content. And we've got first-person character in here. I'm going to right-click on it and create a child blueprint class, which I'm going to call BP_player. And this player, we're going to move to the root of content. Click move there. And then what we want to do is create a new default game mode and set this player as the default to get spawned. But before I challenge you to do that, let's modify this player so that we remove the arms that are there. So when we open up the BP player blueprint, you can see that we've got a bunch of components here. One of them is the mesh.
Yours is different than mine, guy.
Where that first-person character is, and that's under the content first-person blueprints. And we've got first-person character in here. I'm going to right-click on it and create a child blueprint class, which I'm going to call BP_player. And this player, we're going to move to the root of content. Click move there. And then what we want to do is create a new default game mode and set this player as the default to get spawned. But before I challenge you to do that, let's modify this player so that we remove the arms that are there. So when we open up the BP player blueprint, you can see that we've got a bunch of components here. One of them is the mesh 1P, basically mesh first person, which is the arms. And what we can do here is we can simply go down to where we've got the skeletal mesh property and clear that. so that we don't have any mesh selected to render for the first person. Now, if we were to play as the first person player, we'll see that we now works exactly the same, except we've got no mesh arms. But that requires a game mode. So let me refresh your memory on how we create a game. Simply go down to where we've got the skeletal mesh property and clear that. So that we don't have any mesh selected to render for the first person. Now, if we were to play as the first person player, we'll see that we now works exactly the same, except we've got no mesh arms. But that requires a game mode. So let me refresh your memory on how we create a game mode. We go over into a level, we go to the blueprint button in the toolbar, we go to where it says game mode, and we've currently got a Crypt Raider game mode. And what we want to do is go into this and click create, and we want to create a new game mode based off of this Crypt Raider game mode. The Crypt Raider game mode is a C++ game mode, so what we can do is we can create a blueprint version of it to link to other blueprint classes. So let's click on the Crypt Raider game mode, click the root of content, and we're going to call this game mode the BP_Crypt Raider game mode, and hit save. And then we have our game mode launch up like so. So I'd like to challenge you to set up your own game mode. You're going to set it as the project default so that it's being used in any of the levels you set up in this project. Set the default pawn for the game mode to that player pawn that we've just created and removed the arms from, and check that that is the pawn that spawns in your game now. Pause the video and have a go. Okay, welcome back. So first thing, because I'm here in the game mode already, I can select the default pawn class. It's currently set to the first person class, but I want to change it to the BP player instead. I'm going to save that, and then I'm going to go over to the dungeon level. I can select the default pawn class. It's currently set to the first person class, but I want to change it to the BP player instead. I'm going to save that, and then I'm going to go over to the dungeon level, go to the blueprint button, and I'm going to check that our project default, in fact, it looks like we've already done this, the project settings, basically by having created it here, is using the BP Crypt Raider game mode already. So if I go ahead and hit play, you can see the pawn created moves like a first-person pawn, but I no longer have those arms in front of me, which is more in keeping with the style of genre that we've got here. Great stuff. So we've set up our character blueprint ready for some gameplay action, which we will start to do in the following lectures. I'll see you there.
One more lecture. No, inheritance versus composition.
So in the previous sections, we made heavy use of inheritance through our actors. Now, what is inheritance? Inheritance is when a child class automatically has all of the functionality of its parent. We say essentially that the child is a parent. So where did we use that previously? Well, for example, in our moving platforms, we had an actor that was a moving platform actor, and then we had different children of that actor that gave us the spinning, rotating platforms, the up and down platforms, the side-to-side pushers. Those were all children. They all were movers. You could say the moving pusher is a mover. We could say that the rotating baton is a mover. So there is an alternative to using inheritance, which is a bit all or nothing, and this is composition, which is a bit more pick and choose. You get to say that Class A has an instance of Class B. It can choose to use its functionality, but it doesn't have to. It's not tied into being Class B. It can just choose to take the bits it wants. So we say that Class A has a Class B. So let's have a look at some examples of inheritance versus composition using something quite natural, I think, talking about inheritance in the animal kingdom. We might have a class, an actor, say, that is an animal actor, and it has a method on it, which is to live. It lives when you call that method. Now, it makes sense to have things like a mammal that inherits from this because it also needs to live, so it needs all of that functionality that the animal has. But it adds some more functionality, such as making milk. We might also have a reptile that has the functionality, the added functionality of laying eggs. Now, it's fair to say that a mammal is an animal and a reptile is an animal as well. Now, we could go onwards and say, okay, we've got a cow. Well, a cow clearly is a mammal. It needs to make milk, and by extension, it also needs to live because it's also an animal. A snake is a reptile, and it is an animal, but it is not a mammal, so that makes sense too. But what about a platypus? A platypus suddenly needs to both be a mammal and a reptile because it needs the functionality of laying eggs, and it needs the functionality of making milk, and it needs to be an animal. So it gets a little bit confusing here with inheritance, and inheritance can put us in a straitjacket and make these situations really hard to resolve, which is why composition is what comes to the rescue here. It's the has a relationship. So instead of trying to build this taxonomy of classes with animals and mammals, etc., what we do instead is we say we've got a milk making component, and that component has the functionality of making milk. So the cow would have one of these milk making components, and it gets its functionality from there. The snake can have its egg laying component, and it gets its egg laying functionality from there. And the platypus can have both components. It doesn't have to pick and choose one component, it can have all of them, and it gets to share the functionality just fine. So let's take the example that we're going to be using here, where we've got for a mover. We've got something that wants to move. We might have started setting it up as an inheritance and is a relationship. So we've got a mover that inherits from the static mesh actor, kind of like we've done in previous sections, and then from the mover we might inherit a moving door or a moving wall. But what happens if we wanted to do a moving light? How could that be done? We can't inherit from mover because that would make it a static mesh actor, and we want to use a light actor instead as the parent for moving light. How could we resolve this problem using has a relationships instead? Pause the video, have a think about it, get out a piece of paper and jot down some of your thoughts. Okay, welcome back. So this is the way I would resolve the problem. So we could have our moving door and moving wall both inherit from static mesh actor. That's fine. And the moving light can inherit from the light actor. But now the difference is that we include this has a relationship in here as well. So the moving door, the moving wall, and the moving light all can have a mover component on the actor. And this is where actor components come in really handy. And we're going to put this into practice in the next lecture. So I'll see you there.
I'll say that. C++ actor component. Here we go. This is the fun stuff.
Hello and welcome. In this lecture, we are going to be adding a new component in C++ that we can add to our actors to add in some functionality using some composition, essentially. Let's dive in and see how this is done. So I want to add a section of wall that disappears from view when we place an object on it. So what I'm going to do here is I'm going to go to the content drawer and I'm going to search for the dungeon wall in here. And I think I want this one with a nice cut out section where I can stick a statuette. So I'm going to drag this into the scene and I'm going to rotate it by 180 degrees and try and position it accurately. There we go, brought it down to the floor level and it's looking okay. Now what I want to do with this actor is I want to be able to add a component onto it that gives it the capability of moving itself. Now, we've dealt with components before. We've added ones already created by Unreal, but we've never made our own in C++. So that's what we're going to do in this lecture. So what we're going to do is go to this Add button, and you can see there's an option within here to create a new C++ component. Now, within here, there are a couple of options for different...
Holy hell, back it up. Details, add.
dealt with components before. We've added ones already created by Unreal, but we've never made our own in C++. So that's what we're going to do in this lecture. So what we're going to do is go to this Add button, and you can see there's an option within here to create a new C++ component. Now, within here, there are a couple of options for different types of components that we can inherit from, so the different types of component we can build. There is an actor component, which is a component that just sits on an actor, any actor. And then there's a scene component, which is an actor component that also adds in a transform and the ability to attach to other scene components. We don't need this functionality, so we're just going to go for the actor component for now. We will be using scene components later on in the section, though. So let's go ahead and hit next. Now we've got to name our component, and we're going to call it simply the mover, and we'll go ahead and hit create class. And instantly it opens up in Visual Studio for me and Visual Studio Code, and I can see that there is a mover.h and a mover CPP, just like we had with our actors. Interesting to note that the prefix to this class is u. Previously with the actor, the prefix had been a. And the other thing to note is the name of the tick function is different. With a component, this function is called tick component instead, but otherwise it is the same. And if we go over to the C++ class, you can see that there is a tick component function in here. So I'd like to challenge you to log a message on tick. So you can add a new log message, add a component to an actor, add your new component to some actor, and see if it prints the message that you have written. Pause the video and have a go. Okay, welcome back. So let's give this a stab. So in the tick component, we're going to type ulog to get the ulog macro to come up. We're leaving it as a display setting, and in here I'm going to type in mover is ticking, exclamation points, of course. Let's go back into Unreal. Actually, what you can do is do a Control-Alt F11 from any place, actually. You can do it in Visual Studio Code, and it brings up the live coding window automatically.
This might take some time. Bueno.
Automatically, when it's completed, it brings you back over to the editor, just saves you an Alt tab. So what we can do now is you can see this actor does not have our new component on it. So let's go to the Add button. And we're going to search for mover. And then you can see there is a custom component called mover. If I go ahead and add it, you can see it adds it to a separate section to the static mesh components and the other.
I don't see where it is. Oh, fuck, what did I do?
Components up the top. That's because these components here, the ones that are attached to each other, are all the scene components, the ones that have transforms that can be attached.
I don't see where this.
Whereas the normal actor components, the more simple actor components, go in a separate section down at the bottom, and they just go in a list. They don't get attached to each other. So we've got the mover down here, and at the moment it doesn't do very much. Let's bring up our output log and dock it to the layout.
Shit, how do I do output log again?
They don't get attached to each other. So we've got the mover down here, and at the moment it doesn't do very much. Let's bring up our output log and dock it to the layout. And let's go ahead and hit play in the game, and you can see that we are indeed getting mover is ticking displayed in our output log. Great stuff. We've created our first actor component in C++. I'll see you in the next lecture.
All right, I think that's a good stopping point. Oh boy. I am going to exit out. So this guy.